Semiconductor. Today we talk about semiconductor. Semiconductor is two types. First, intransonic semiconductor and transonic semiconductor. What is a intransonic semiconductor? The pure form of silicon and germanium semiconductors is known as intransonic semiconductors. Now we talk about doping. What is doping? So let we talk about doping. It is a process of add the proper impurities like pentavalent examples argentinum, Sb, phosphorus, etc. and three valent like aluminum, germanium, yttrium. In the intrinsic semiconductor materials is known as doping. It is a special process which is called doping. Now we talk about intrinsic semiconductors. What is the extrinsic semiconductor? So after doping with the proper impurities, materials become impure. This impure forms of materials is known as extrinsic semiconductor materials. ICS मतलब intrinsic semiconductor plus pentavalent equal to n-type semiconductors and intrinsic semiconductors plus trivalent equal to p-types semiconductor which is called holes. Pentavalent means n types N P S B B I. Trivalent BAL मतलब aluminiums CN or IN. Now note that difference between vacuum tube and solid state. Vacuum tube. What is a vacuum tube and solid state? So now we talk about difference between vacuum tube and solid state. Vacuum tube size is large and solid state size is very small. Vacuum tube have feet and triangles. Solid state lightweight and non-friable. Vacuum tube high operating voltage and solid state low operating voltage. Vacuum tube high power dissipation, solid state lower power dissipation. Vacuum tube reliability is less and solid state reliability is high. Vacuum tube life is less and solid state life is high. Warm-up period of vacuum tube is required and no warm-up and instant operational for that and capable to hold high powers and frequency for vacuum tube and for other no warm-up and instant operations for vacuum tube capable to hand and not match affected electric static discharge and others it is more variable. Now we discuss about solid state device. It is completely solid and having no gaps in between any 2 points. So now further we talk about majority and minority current carrier in semiconductors. Conductor flow in semiconductor materials due to electrons and holes. They are called current carrier. In p-type semiconductors materials current flow will take place due to holes. Means in p-type semiconductors current will be always flow by through holes are majority current carriers. In p-types is holes, and semiconductors and electrons are semiconductors, and in p-types semiconductors electrons are minority current carrier. So further, in n-type semiconductors materials current flow will take place due to electrons. Electrons are majority current carrier and holes are minority current carriers in n-type semiconductors. Type of electronic semiconductor. Extrinsic semiconductors. Extrinsic semiconductors are two types, p-types and n-types. P-types are called donor impurities, arsenic and Sb. N-type semiconductor are acceptable impurities, GaIn. Note that a voltage of approximately 0.7 voltage is needed to begin the current flow over the potential hill in silicon semidiode. Note second is that a voltage of approximately 0.3 voltage is needed to begin the current flow over the potential hill germanium semiconductor diodes. In this figure you can look that note first and note second. So now we came in next topic, that is p-n junction diode. With a special process, p-types and n-types joint are called p-n junction. In a region some holes make ions, that is positive, near the junctions, and electrons make negative ions is n-type materials near the junctions. These ions are fixed in the forms of crystals and do not move and make depletions zone in both the p-types and n-types materials near the junctions where no current carrier exists. Further, those ions create an electrostatic field which is called potential barriers or potential hills in the cases of silicons 0.7 voltage and case of germanium 0.3 voltage. Depletion zones. Depletion zones means where p-types semiconductors and n-type semiconductors include to each others, and on there is a gap provide, and on there is a depletions means space, make a space. Okay, note that is in reverse biased the depletion zone is increased and high value of resistance. Depletions create always high value of resistance. In the forward biased, low value of resistance is provided by p-n junction diode. Operations of p-n junctions. It can be operated extremes of two way. First is forward biased and second is reverse biased. When anode is applied with positive potentials and cathode is negative potentials, majority current carrier in both the regions cross to the junctions and current flow take place. In reverse biased, when anode is applied with negative and cathode is positive, then depletion zone is increases and no current carrier passes through the junctions, hence current flow the diode. What is a leakage current? In reverse biased, cancel due to minority current carriers, a very little amount of currents flow take place in diode, which is known as leakage current. What is the leakage current? In reverse bias, it is always doing in reverse bias. Conditions is that due to minority current carriers, a very little amount of current flow take place in diode, which is known as leakage current. Diode parameters. What is the diode parameters? Use of diode in electric current. The informations required for the considerations are follows. First, forward current. The maximum current can pass through the diode safety in forward biased conditions of the PN Jackson diode is called forward current. And second, now we talk about reverse voltage. This is also known as peak inverse voltage, PIV. The maximum voltage in reverse biased conditions, the PN junction can be standard, is known as PIV. Third is forward surge current. In the maximum current can be passed for a very short times in forward biased conditions without tapping the junctions is the many times more than forward current. Now we discuss about forward voltage. Through it is considered that the diode work like a cabbage switch, hence there should not be any voltage across the diode, but in practice some voltage is found across the diode in forward biased conditions is because of bulk resistance and potential barrier. Thus the maximum voltage drop at full forward at related forward current is known as maximum forward voltage. Reverse current, also called leakage current. Reverse current is always called a leakage current. In reverse biased conditions, a very little amount of current in UA know that is microamperes flow due to minority current carrier in the semiconductor material is known as reverse current. Reverse recovery times, the times taken for changing from FB to RB. It is very important factor in applications of higher frequency. Seventh, that is power dissipations. The maximum amount of power I square R means heat that a diode can dissipate means throughout in forward biased. It is maximum operating temperatures. It is maximum temperature that a PN junction can be stand without change in performance unit is Celsius per watt. Notice that in semiconductor materials forbidden energy gap is 0.1 voltage to 0.6 electron voltage. Above semiconductor voltage is insulator and below 5 voltage electron voltage is conductor. Conductions band electron high energy level. Valence bond O is low energy level. When conditions bond conductions bonds electron going to valence bond holds the energy release, and when valence bond holes is go to conduction bond energy gain. Diode identifications. The system uses numbers and letters to identify the different type of semiconductor device. The first numbers in system indicate the number of junctions. First is indicated the diodes, second is indicated the transistors, third is indicated the testrode. N is indicated the semiconductor device. Examples 1 and 34(5)A. First is diode, N is semiconductor, A is impure visions types 345, 345. There are two types of affected. First is advantage is affected, and that means due to heat and impurities. Due to this effect, life of diode is decreased. Second is Zipfer effect due to voltage. Due to this voltage, life of diode is not decreased, and in Zener diode, a very low voltage is causes of Zener effect. There are many kinds of diode, but generally three types: Zener diode, photodiode, LED. Zener diode. It is always reverse biased. In this diode, doping rate is higher than other. In Zener diode, always use a resistance for doping the extra voltage. It is used to power supply as a voltage regulations for stable the voltage anode and cathodes. That is the symbols of Zener diode. Now we discuss about photodiode. It is also always in reverse bias. It is also called sometimes photocell. When light energy photons flow in the depletion zone, current carriers are generated allowed current to flow. And LED, light emitting diode. It is always in forward biased. In this diode, electrons across the junctions and fall into holes as the electrons of conduction band fall into the valence bond and radiate energy. This energy is dispersed as light by using the elements according to their wavelength and frequency. LED, light emitting diode, can be designated to indicate colors such as red, blue, etc. It is used for indications purpose. And power diode. It is used in power supply systems. Skip for flow required forward current and safety for reverse voltage. Power diode are available from 1 ampere to 100 amperes and reverse voltage from 50 voltage to 1000. It is generally operated in forward bias, but any one time operated in reverse biased. Schottky diode. Scotchy diode. This is diode which is having no p-n junction in it is n types and metal junctions. It is used in very high frequency systems where TR required is very less and voltage drop across junctions is also very less, like 0.15 voltage. This types of a diode is considered a uniparallel diode because free electrons are the majority carriers on but side of the junctions of Schottky diode has no depletion zone or charge storage. And Schottky diode symbols. Varistors. It is not a semiconductor diode, it is made of zinc oxide. Varistor has high resistance at low voltage and low resistance at high voltage. It is a resistance depends upon voltage across the varistor. After a certain voltage, the resistance of varistor suddenly decreases, hence a sudden having current flow through the varistors. It is mostly used for voltage protections, that is symbols, and Varactor diode. It is also known as varicap. Due to this, we have just like a variable capacitors. It is capacitance depends upon the applied voltage. It is operated in reverse by PN junctions for functions like dielectric and PN materials, just like a plate. When the voltage up depletion zone increased or varied, then high resistance and low current between the terminals, C equal to A K by D. Increasing depletion zone are wide of gap between plate in reduce the capacitance of the PN junctions. It is used to replace the old styles variables capacitors turnings. It is used in turning circuit. Varactor diode, that symbols. One of advantage of varactor diode is that it is allowed to DC voltage to be used to turn a circuit for simple remote controls or automatic turning functions. Use of diode. Diode can be used for various purposes. Some of them all as follows. Voltage regulators. When diodes are connected in series across a supply lines, voltage across networks of diode remains constant 0.7 voltage into remember of diodes in irrespective of current as a capillary diode and resistors. This is also known as diode limiter. With the help to diode, this CCT CAN eliminate means remove theta certain portions of the signals. This maintained only required output. Clippers is further known as positive and negative capillaries. Clippers, clampers, diode and capacitors, also known as DC resistor. Diode can be used to make AC voltage into pulsating DC, and also it can overside a signal over a DC voltage which is also known as clamper, and a capacitor also use rectifier. It is used to convert AC to DC. It is further the three types H, W, FW and bridge. We talk about to rectifier in next video. So bye.